Welcome to the another video on the basic electrical engineering, and here we are going to learn about the mesh analysis. It is related with the previous video where we discussed elaborately about the concept of the mesh analysis, and here we are going to touch on the mesh analysis and do some numericals on mesh analysis with the help of mesh analysis. So here what you can see an example is there. That's in an example where the R1, R2, R3, R4, R5 are the five registers are there, and there is a known Vx, Vy voltage sources and a current source I is there. So by using this example is being solved over here using a mesh analysis. This network is being divided into three independent meshes: mesh 1, mesh 2 and mesh 3. In mesh 1, we are assuming the clockwise direction. Here also we are assuming clockwise, and here also we are assuming clockwise. Any student, if you want, you can assume in the anti-clockwise direction or clockwise, both vice versa. But once you are assumed the direction of the current, accordingly you will write the equation. So best thing is that you can make this direction clockwise in all or anti-clockwise in all. That will give you suitability in writing the equation. So if assuming it in a clockwise direction, we get a right equation. When you move in the clockwise, first we encounter here the minus sign over here, so we are writing is minus of Vx. And then we are encountering what? That we are encountering here R1. Then when you say R1 and we are moving in the clockwise, we are getting the plus sign over here. Then again we are adding plus IR1, R into I1 or I1 into R. Then again we see the plus sign, then plus Vy. Again we see a plus and minus, then we are saying plus again. But this R4 is sharing the current. One is I1, which is going from like top to bottom, that is our reference right now, and I2, which is moving from bottom to top. So it is trying to oppose the opposite. So like I1 minus I2, and net current is I1 minus I2 multiplied with R4, and that's all. So we are adding up 1, 2, 3, 4. So four things are added up over here, and that is equal to 0. Similarly, when you write the equation for mesh 2, and we move it like this. So here one thing is to keep in mind that when we are writing for I2, right? So you have to write a sign according to it, plus minus. So voltage, the sign across the voltage doesn't depend on the direction of the current, so it will be as it is. So now if we move it from here, so it is R4. And we are talking about mesh 2, so I2 is the one which decides the sign. So it is the I2 is a current which is going from bottom to top, but I1 is a current which is coming from top to bottom. Obviously this I1 is getting subtracted from I2, so I2 minus I1 is the net current. So net current into I4. Then you move up, you will get a negative sign, so minus of Iy. Then you again going forward in the clockwise direction, you find it a plus sign again, then R2 multiply with I2, right? So then again you get a plus and minus depending on, because your reference is I2 here right now in mesh 2, so you have got a plus and minus like this. What you observe here, I2 is moving from top to bottom. However, the R5 is sharing between two meshes, and the current on the R5 is moving upward. So it is actually I2 minus I3, that is subtracted over here, that is multiplied with R5, and that is equal to 0. That is how you can get the equation for mesh 2. Now for equation for mesh 3, suppose I will write and I can write what is the thing is good thing about the mesh 3 is that there is a current source in a mesh 3, and this current source is there only sharing with the mesh 3. It is not sharing with anybody else. So this mesh 3 is not being shared with anyone. It is shared in the mesh 3 only. And now if we know that current source means in this wire only the current which is flowing in this wire is I, which is already given. So this I3 this I3 has to be equals to minus of I, because I3 direction that we have assumed is in clockwise, but this I is moving upward, so it is minus of I. So this I3 is equals to minus of I, looking at from here. So I3 is equal to minus of I, we can write like this. So If somebody says, sir, I'm not interested for writing in this way, rather I want to write in a conventional way of writing the voltage, then what can we do? Yes, what can you do is that suppose you can write this as a plus and minus, and you say that the voltage across this current source is VA, or let us say any other name like VA. So then we can write, but if we write like this also, we can write R5 into I3 minus I2, R3 into I3, then plus VA. Then unnecessarily we are doing it, because ultimate our objective is to find the value of these three currents. Once we know what is the value of I1, what is the value of I2, what is the value of I3, our purpose is completely solved. So our purpose is solved once we know these three values of the current. Because if you know the value of I1, I2, I3, you can get the current through R1 is asked. Oh, this is I1. What is the current through R2 is asked? This you say I2. What is the current through I3 is asked? You say I3 is a current which is going for R3. Or somebody is asking what is the current through R5? You will say, okay, what is the sign you want? So they say like this. So you will say I2 is the current which is top to bottom, and I3 is the current from down to up, and then you can say I2 minus I3 is a current which is going through this R5. In that way, we can use a mesh analysis and solve it. Let us take an example, because without example it is not possible to understand that how we will solve this. So let us take an example of here. What you can see in this mesh analysis, we are taking the same example that we have taken for the node analysis, and by using node analysis we solve it and very easily. So here, if I use a mesh analysis, so first I have to decide which one I will take the mesh as. So let me take any one of the mesh. Let me take a convention of it. Let us take a convention like, okay, anti-clockwise. Let us choose. Let us say anti-clockwise, because you can choose a clockwise also. But I find it anti-clockwise because here in this mesh you can see that the direction of, if I choose anti-clockwise, my current direction is matching with 2.5 ampere, and if here I am using anti-clockwise, it is matching with 5 ampere. So I little bit have to smart and choose in that way. So let us say 1, 2 and 3. So we have decided to choose 3 mesh. The good thing about in this problem is that we do not do lot of work, because in mesh 1 you can see that in mesh 1 and mesh 3. So mesh 1, what is the good thing about, in this wire whatever the current is flowing is 2.5 ampere is already being decided in this wire. So how could be I1, the current in mesh 1 is, let us say I1 is the current in mesh 1, current in mesh 2 is I2, current in mesh 3 is I3. Instead of writing like this, so instead of writing like that, we can just we can erase this way, and we will not write in this way. Rather, we will write in a general way and say that this is a current is I1 here, and this current is I2 here, and this current is I3 here. In that way also we can write these equations. Let me use it another page, and so that you can have like this, you can have a lot of space on this side. So here we have I1, here you have I2, here you have I3. So let us write for mesh 1. So you can write that applying KVL, Kirchhoff's voltage law in mesh 1. But you find that in mesh 1 I'm not going to use the KVL, because when I say KVL, there must be like all the voltages. So from mesh 1, rather than writing like this, we can say that from mesh 1 we can write the equation from mesh 1 that I1 is equals to 2.5 ampere, because there is a current source in mesh 1 not being shared with any two meshes. It is shared in only one mesh. So I1 is equals to 2.5 ampere. So this is one equation. Similarly, let us take the mesh 3, because in mesh 3 also in this question it is very easy, because in mesh 3 I need not to apply any KVL. Simply I can write that I3 is equals to 5 amperes. So I3 is equals to 5 ampere. This is another equation. Third equation that I will get from mesh 2 is this. So here I will use the KVL, applying KVL and Ohm's law in mesh 2. So now you have to see that, okay, let us start from this 12. When I'm talking about mesh 2, so the current is in this direction, I'm moving in this direction, so my sign convention are very simple now. So it is just has to like plus and minus as I'm moving, because all are resistors and there is no voltage source over here. So I can write here 12, and here the current is moving up is I2, but there is a current which is opposing is I3. So I will write here I2 minus I3 is the total current through 12. Again 8, and the current which is going in the clockwise, anti-clockwise is I2, and which is opposite is I1. So I can write here I2 minus I1 again. Then here also, but 4 ohm is not being shared with anybody, so 4I2 is equals to 0. So this is how our third equation is ready. So in this equation that we can, let us take all the coefficients of I2. So we have 12, this is 8, and this is 4. So it is equals to 24. I2 is one common point. Another is 12, take it as I3, that is 12 of I3. And then we have I1 is there, so minus 8 of I1, and that is equal to 0. And this is how we get the third equation. So we have now got a third equation. So from the top we can get the value of I1 2.5. So we will write here 8 into 2.5, and here I3 is 5, so 12 into 5, and here 24 into I2. This is what we need to solve and get. And then what we get is the, here from this we can write that I2 is equals to 3.333 ampere. So this much ampere is I2. So now we have got the value of I1, we have got the value of I3, and we have got the value of I2, right? So what we get is here value of I1, I3 are already there, and I2 what we calculated, and we get we have calculated I2 from this from figure, and from this I2 value is written over here. So the same problem we have solved using the node analysis, and now same problem we have solved using the mesh analysis. While solving it by the using node analysis, we got the value of here V1 is equals to we get the value of V1 is equals to how much? V1 is coming around 13.33 volts, and here V2 we are getting around 20 volts. So let us verify that by using node analysis we got a 20 volts, by using mesh analysis are we getting the same value or the different value. Suppose let us say the current through this 8 ohm. Okay, let us find out the value of the voltage across this 8 ohm, or the current from like this current which is moving in this direction. So that is nothing but we can find this value of the current I. So this I is equals to this V2 minus of V1 divided by 8. So we can calculate like this, like 20 minus 13.333 divided by 8, and that will come out to be like I is equal to 0.833 ampere. So this I, which is moving from like 2 to 1, is, if I see from the mesh analysis, I think nothing but this I must be equals to this I must be equals to here I2 is a current which is moving from right to left, and I1 is a current which is moving from left to right. So I2 minus I1. So I2 value is how much? We get the I2 value is 3.333 like this, and minus I1 is 2.5. So this will add up to how much? 0.8334. So that is how we are getting the nearly the same answer. This change in answer we are getting because of some decimal. So here value of I, whatever we get, like if we take this decimals up to, we are getting nearly the same answers. So that is how, if I have a mesh analysis and we solve the same problem using mesh analysis, so we can easily solve and get the value of current, and we can also say what is if question is asked what is the value of the current I, so one can immediately say, okay, this is I2 minus I1, that is 0.83. We just verify that node analysis also, we have find out the value of 20 volt and 13.33 volts, and by using node analysis also we can give the same answer, I is equal to this much. So this is how we can verify the mesh analysis and node analysis and cross verify and get the same answer. If the answer is correct, that is true. So let us take another example, and here the example is a bit different. In this example, how many meshes is possible? So obviously you will say, sir, there are the 3 meshes possible, and you can have 3 independent like mesh. So we have taken a 3 mesh over here, and which one will take 1? Let us take as a 1, and let us take everything anti-clockwise. If we take anti-clockwise or clockwise, doesn't have any problem, but let us have some any direction we can choose. Let us say this is I1, and another one is, let us say this is I2, and let us say another mesh we have, that is I3. So we have got 3 mesh over here. In this question, there is one point is there is a dependent source is there, that is 2ix. So don't worry about the dependent source, just treat it as your current source right now. And remember that if there is a ix is there in a network, there must be ix written somewhere else. So right now just keep it as it is and write down the equation. So if I go on writing the equation for mesh 1, how does it look like? So I am moving in the here anti-clockwise. I'm making my reference as anti-clockwise, and current is I1. So all the sign that I will give across the element is depending on the anti-clockwise direction. I will give the sign according to it. So after giving a sign, so we will start with, for the mesh 1, applying the KVL. You need to write applying the KVL and Ohm's law. In mesh 1 we can write starting from here. Let us start from here, like 4. So you can say 4 multiply with only one current is 4 is shared in the one mesh, so 4I1, that's all. And then we move on, there is a 8, again plus sign is there. So what is the current? I1 is the current which is moving from left to right. So okay, I1 is the current, and what is that opposite to that is I2 is the mesh. I2 current is a mesh current which is opposite to it. So I2 is opposing. Similarly, you have got a 2, so you take it a 2. Then I1 is a current from left to right. Okay, I1. Then you have I3 is a current which is opposing it. That I3 is equal to 0. Don't worry about this Ix. Is the given the current which is flowing from the 2 ohm. That is mentioned, because this Ix is somewhere related with the current source, dependent current source. So like that we can have like one equation is done, and you can have a one equation done for mesh 1. Similarly, suppose you have a mesh 2. So if you have a mesh 2, the good thing about in mesh 2 is that there is a current source in mesh 2. So once there is a current source in mesh 2, in this wire we know that this current source says that in this wire only this current will flow, that is 2Ix will flow. No other current is going to flow through it. So then I2 has to be equals to 2Ix. Yes, we can substitute the value of Ix from here, like Ix is what Ix, we can do it later on, but right now it is a dependent current source, but this is a current source. The current source means in this wire the current which is flowing is 2Ix, and I2 is obviously equals to 2Ix, because the direction of I2 is same as the direction of the current source. So that the good point is that we get a very easy equation in a mesh 2. And then we have a mesh 3. In mesh 3, again we have a very easy equation, because there is a current source in this wire, and this wire is like clear current source is there. So we have got I3 is equals to how much? 3 amperes. So here I3 value is also known. So in this way we have just taken the mesh 1, mesh 2 and mesh 3, and we find. So in this way all the elements is considered, but here you find that the element 4 is not considered yet. This 4 ohm resistor is not there in any of the, like this 4 ohm is here, but this is not being considered. So do not worry about it, because our objective is to find the value of I1, I2 and I3. So anyway, we have get the three equations. Let us see from this mess one, can we make it an easy one equation or not? Let us try to find it out. So if here, let us take all the I1 things common, 8, 9, 10, 11, 12, 14. So we have got 14 of I1. Then you have got minus of 8 I2. I2 is connected to minus of 8. Then we have 2 minus of 2 I3. That is what we have. So now we have got this equation ready. So we have got this equation, so we can give name 1, we can give it name 2, and we can give it name 3. So we have got three equations. The Ix value, from here we can say that what is Ix? Ix we can say is nothing but I3 minus of I1, because Ix is the current which is going through 2 ohm, right? So I3, so I can write Ix is equal to I3 minus of I1. So if I write I3 minus of I1, that is okay. So that is how we get a 4 equation done right now. So what we get is this 4 equations we have got here from that, we can say this 4 equations that we got, 1, 2, 3 and 4. This 4 equations that we got, and these 4 equations we need to solve it. So we can substitute the value of I3 and Ix. So let us substitute the value of Ix first here in equation 2. So what we get, you can say it equation from equation 4, substituting the value of Ix in equation 2. So we can write 2 of Ix is equal to I3 minus I2. So sorry, I3 minus I1, and here I3 value is how much? 3. So 3 minus I1, that is equal to 6 minus 2 I1. So I2 value is known to you, and here you have also this equation you can rewrite, that is 14 I1 minus 8 I2 is equals to, this one you take it on the right hand side, 2 I3. I3 is how much? 3. So that is equal to 6. So this equation is also there. Let me write these two equations properly. So you have got I2 minus, so this will be plus, this thing will go on the left hand side, 2 I1 is equal to 6. This is one equation. From this one, I just derived this one from here, and here also you have got 14. Let me write the all I1 term in one side, that is all I2 term also in one side, that is 8 I2 and minus 8 I2 plus 14 I1 is equal to 6. So what we can do is, it's very look simple. Here I will multiply 8. So after multiplying 8, what I get again, 8 of I2, and here I get 16 of I1. Here 8 is 48. I get it like this. So here I will just have to do is add these two equations. So here I will get here 40 I1 is equals to 50, and what is the value of I1 you can easily calculate from here. So here we are getting this is not 40, or this will be coming around 30, and 30 I1, and this will be 54, and from that we will get 54 minus 54 divided by 30, we will get nearly around 1.8 amperes. So here we get the value of I1 is equal to 1.8 amperes. So that is what the value of I1. So finally we get the value of I1, and I1 is equals to 1.8 amperes. So by substituting that, we will get the value of I3 is already there. So it is around 3 ampere, and then Ix, we can, okay, let us write I2 also. I2 is 2 times of Ix, so for that we need to find Ix first. So Ix is equals to, we can write in small letter or whatever the nomenclature mentioned here. Ix is equal to 3 minus of I1, so that is around 1.2 ampere. And now you have got I2 value also you can write, or 2 times of this Ix, that is 2.4 amperes. So like that, now I have got a list of all the values of the current that is being given in the equation, asked in the equation. In this way, so we, by using a mesh analysis, we have solved the same equation. Probably in the node analysis, while we are solving this, this equation becomes very tedious. Let us verify from the node analysis. So from the node analysis, we have calculated earlier and find the value of V1, V2 and V3. V1 is 4.8, V2 is 2.4 and V3 is minus 2.4. We can verify any one of it, like you can take it like whatever the current is flowing from, like from this 8 ohm. So the current which is flowing from 8 ohm is nothing but V2 minus V3 divided by 8, and that is equals to this current must be, let us say this current is I, and the same current is I must satisfy. If I write here I2 is a current which is going from right to left, and I1 is a current from left to right, so minus of I1. So these two values must satisfy. So we just calculated and find that by putting 2.4 minus of minus 2.4 divided by 8, it is coming 0.6, and then we get it from again I2 minus I1. I2 value is here, I1 is here, so you just take that subtract it, I2 minus I1, you will again get 0.6. Like that, you find that from the mesh analysis whatever the answer we got, and from the node analysis whatever the answer we got, we are matching, and all these things is matching. So Ix value is also like 1.2 ampere is given. So here whatever the value of I2, 2 times of Ix, so I2 is 2.4 amperes, so that is also defined. So this node analysis and the mesh analysis are helpful for solving any network in an easy way. But what is the difference what we find in this example? Node analysis, we are getting a lot of equations are there, like 3 independent equations for 3 nodes, and we are solving it a very difficulty. So what is the point to learn here is that in a mesh analysis, you use it mesh analysis. If you have a current source in one of the mesh, so good, go for mesh analysis. And suppose you have in a network you have a voltage source in one of the mesh, so you can go for a node analysis. Or number of nodes are less, only 1-2 nodes are there, or 3 nodes, between 3 nodes is done, so you go for a node analysis. So like that, we need to do either a mesh analysis or node analysis. There are various cases of mesh and node analysis that we will learn in the next session, and we will learn how and when mesh analysis is used for different conditions. However, this mesh and node analysis, once you know, it can be implemented in any of the circuit, and it is easier than applying the circuit by using KCL, KVL and ohms. So you can have you can apply these 3 only, or you can have a node analysis or mesh analysis. So by using these 2, you can easily solve the network. However, by using this, you can easily solve a complex network. If it is more complex and then more complex, but it is a less number of elements are there, okay, this is good. So I will suggest that node and mesh analysis can solve any bigger network in a very simplified way. And to get a voltage across, like 8 ohm is asked, then you go for KVL and find out. Suppose what is the current through this, what is the current which is flowing from 4 ampere. Now once you in a mesh analysis you got an answer, then you can find out what is it by using KCL. If these 2 currents are known, what is the current through it. Like that, you can implement either of them and you can solve the problem. In the next video, we will be learning about the case studies of different node analysis and different mesh analysis. Thank you very much.